Well, welcome back, everybody. Here we are in section 2 of chapter 3, and so we're going to break it up into two pieces. Part 1 and part 2. Substitution is the first one. So we are in the business in this chapter of trying to solve equations, but it's called a system because you have more than one equation going on. Previously, you guys were graphing two equations, and you were seeing where they crossed. So when they actually cross and they intersect, that's when you call it consistent independent. When they were parallel, you had inconsistent, and then when they were the same line stacked on top of each other, you had the consistent dependent. So now, what happens when you can't really tell on a graph where it crosses? We can actually solve them algebraically. You're going to see that. There's two techniques right off the bat. The first one's substitution, so we'll cover that one in our first section, or the first part of this first section. Okay, so here we go. So as you guys see on this page, just something, a little blurb about this so you can see it in writing as well as me saying it to you. Graphing is not the best method if you're trying to find an exact solution always. It doesn't always cross at the crosshairs. So when you're trying to graph something and you've got, tick marks like this, but it ends up your point is kind of in space right here, that's not really exact. You need it to be more right here on the crosshairs, and that helps you a lot more. So yeah, we're going to have some fractional answers, but that's why we're going to do it algebraically today. Alright. So here's an example. You kind of see where the arrow is pointing that this intersection point is not necessarily exactly on the crosshair point. So we're going to do this problem, well, maybe not this exact problem, but another problem algebraically. And so you're going to see that happen. So here you go. A word about substitution. Substitution is a great method to use when you have one variable in one of the equations where it's already by itself. So when you have substitution, you want an isolated variable, okay? Or it has a coefficient of 1. So like if it said y equals and it's had like 2x minus 3, the y is already by itself. So you're in great shape to substitute into the other equation for the y value, because y equals 2x minus 3. So we can sub this in right here. The other one where coefficient of 1 is where you have like, we'll use 2x again, plus y equals 1. Well, that y value, since it has a coefficient of just a 1 right there in front of it that you can't see, it's understood, that's great because we can move the 2x away and have just y equals. Alright, so here we go. We got a busy problem, busy page here. It says solve the system using substitution. So I want you guys to look at is, let me get my little pointer right here. I need you to look at the y equals 4x and x plus 3y equals negative 39. Those are your two equations in our system. And notice my circle's a little off. It says since y is already isolated in the first equation, substitute the value of y for y in the second equation. So basically, guys, let's take 4x and put it in for that y right there. So take this y out and put what y equals, which is 4x, in for that y. So you see that done right here. So we use the second equation, and when you see the y value, you plug in 4x. Simple as that. And so you see how they finally go in and they put 12x, 13x, divide both sides by 13, you get negative 3. Alright, let's go to the next slide. Now I need you to understand that at any time you can always pause the video and recap what we've just talked about or try this on your own. Alright, so this slide, what we just discovered is that the x value is negative 3. Alright, we see that show up right here in our answer here in a minute. So I'll just note that for you guys. So we have y equals 4x. We just found out that x equals negative 3, so that's why we put in negative 3 in for x. Because it was 4x, now it's 4 times negative 3, and we get our new y value of negative 12. So write the solution as an ordered pair, negative 3, comma, negative 12. So we put that together. My slide shows a little off. And there's your negative 12. That would be your POI, your point of intersection. These are good numbers for us, good integers. Alright, so pause this, go back through it. Now, we've solved for x, we've solved for y. We need to go check our answers and make sure they're correct. So you see here, we have our two equations, once again. Let me highlight these. So there's our two equations. We go back through and we put our x value. Our x is negative 3 and our y is negative 12. So in both equations, let's put those values in here. So you plug them in and you see if they check out. So y equals 4x, so negative 12 is 4 times negative 3, which is negative 12. That works. Good. The p is supposed to be a check mark in the slideshow. And then the other one is negative 3 for the x. So you see how that drops down. And then 3 times the y, which is negative 12, you see how that drops down, equals negative 39. So when you plug this in, it actually works as well. So we're in good shape. We've got everything working for us. This is an exact answer for our POI. Okay, on this problem, I need you guys to take a look at it. We don't have, first of all, here is our question. These two equations in our system. Alright, there's some more work shown down here. But above, we have one variable that's by itself. That is the key. When you find a variable that's all by itself, 1x, 1y, something like that, that's the one you want to solve for so that you can substitute. So if we go over here and we take x minus 3y equals negative 5, what we can do is we can add 3y to the other side, and you've got x equals 3y minus 5. And so that's what you see right there. Okay? So they've got it set up. So every time they see an x in the other equation, 2 times x, you're going to see them put in 3y minus 5. So x is now 3y minus 5. You see that connection? And they solved this out. So let's go to the next slide. We'll see it solved. So here you go. 2 times 3y is going to be 6y. And 2 times negative 5 is negative 10. And then plus 7y drops down equals 16. It's a little out of order right there. So here's our new equation right there. We are going to add, we are going to add our y's together right here. And right there you get 13y. And minus 10 just drops down, equals 16. It looks to me like they have added, let me write it in here, 10 to both sides. So you get 26. 16 plus 10, 26. Divide both sides by 13, and that's how you get your 2. Alright, so y equals 2. We got to go find our x value. So pick either equation you'd like to solve for x. But notice how this top one is already set up to solve for x. Okay? So 3 times y, which is 2. So 3 times 2 is 6. 6 minus 5 is 1. So here's your y value. Or your x value. So your solution is 1 comma 2, like they have here, but we'll write it together. Okay? Let's go check our answer. Alright, so here you go. I've got the top equation first. X equals 3y minus 5. Over here, you see is our answer, our point of intersection, 1 comma 2. So 1 is the x value, so I'll put it in for x, and 2 is the y value. I'll put it in for y. So when we crunch this out, 1 should equal 3 times 2 minus 5. 6 minus 5, 1 equals 1. Awesome. It works. The next one, we have to check both. So you have 2x plus 7y equals 16. Plug in your 1 again for the x. There it is. Plug in your 2 for the y, there it is. And so 2 times 1 is 2, and 7 times 2 is 14. 2 plus 14 is 16, which equals 16. Boom. You got it. All right, so this will not always work. Sometimes you might get one that messes up. And sometimes you may make a mistake yourself. So make sure you are careful about this. Again, you're pretty comfortable with your calculator now, but we got to also do this algebraically. So this is another example of some things that will be required to do. When you have your choice, of course, maybe the calculator is simpler, but by hand, you can never replace that. Technology may glitch for you, but by hand you always have that mental skill set that you can always rely on. Okay, so that's section 3.2 part 1 with substitution. Coming next, elimination. All right, be ready. Remember, flip, don't flop.